video is a continuation in the Properties of Matter unit, the first unit that we're studying in chemistry. Well, chemistry is the study of matter, and now we're going to look at some properties of matter. And we're going to specifically look at chemical properties, and we're going to tell a difference between a chemical property and a physical property. Now, sometimes this is a little bit confusing. The way that I tell if it's a chemical or a physical property is that I ask this question: are the properties determined without changing the identity of the substance? If you say yes, the property can be determined and I'm not changing the composition of my matter, what it is made of, its identity stays the same, then that is a physical property. And we're going to look at some examples of this. If you say, well, this property cannot be determined without changing the identity of the substance. So in other words, it's changed into something completely new, usually because it's interacted with something else, then we say that it's a chemical property. So again, you ask the question, are the properties determined without changing the identity of the substance? If it is not changed, then it's a physical property. If it is changed, then it's a chemical property. So let's be more specific and look at chemical and physical properties. Everything in red from here on out will be referring to chemical properties, and the blue will be physical properties. We're going to start with physical properties. They can also be classified as intensive or extensive properties. So an intensive property is something that does not depend on the amount of matter that you have. So something like its density or its melting point. It doesn't matter how much you have, that property is independent of the amount that you have. An extensive property does depend on the amount of matter that you have. So in other words, the more matter you have, the more of that property you have. Like mass. So if we were going to get the mass of a piece of gold, the more gold you have, the greater the mass would be. That's called an extensive property. Now, a chemical property, they're all intensive. All chemical properties are intensive, which means it doesn't matter how much you have. A chemical property, you're going to be asking, how does this substance interact with other substances? So in other words, how does it react with air? Or does it react with water? Does it react with acids or bases? It doesn't matter how much you have, they're all going to react the same. Now let's go ahead, and not only do we have chemical and physical properties, but we have chemical and physical changes of matter. Now in a chemical change, you're going to form something new. You're going to form one or more new substances. With a physical change, one or more of the physical properties are going to be changing of your substance. So something like the size. So if you had a piece of paper and you crumpled it up, is it still paper? Did it retain its identity? Yes, it's a physical property, but you changed its size, so that was a physical change. Phase changes, and we're going to come back to this at the very end. What I mean by a phase change is that matter has changed from, say, a solid to a liquid or a liquid to a gas. And those are all physical changes. Now, let's go ahead and talk about chemical changes. Here are some signs that you've had a chemical change. In other words, you have formed a completely new substance. So, first of all, there could be a release of energy. And that release could be in the form of heat or light. So you look for temperature changes. There could be the formation of a solid. And that solid is sometimes called a precipitate. So when you get a solid forming, if you mix two solutions and a solid comes out, we say that's a precipitate. And we're going to be making some precipitates in our next lab. Color changes are also a sign of a chemical reaction. The chemical bonds are being broken and formed in a chemical change, and sometimes they're interacting differently, giving off different colors. Also, a formation of a gas is a sign of a chemical change, and a clue that a gas is being formed is that you'll see bubbles being formed. Now let's go back to the phase changes that I talked about. All phase changes are physical changes. We don't change the identity of the substance. We're just changing its form. And I just wanted to get some vocabulary out there, and a lot of these words I think you already know. We're going to deal with the three main phases of matter that we have at our room temperature. We have solids. Again, in your mind, I want you thinking about solids as atoms that are close together. They're still moving a little bit. They're vibrating a little bit. If you give them a little more energy, then you've got a liquid. And your atoms or your molecules are able to roll past one another, and they have more degrees of freedom. And then the gas is the highest energy state for matter that we see, that we're going to be talking about here. And I want you to think about gases as molecules that are just bouncing off the wall in continuous motion, hitting one another, kind of like in the lottery drawing where they have all those balls bouncing around. That's a gas. They're in constant motion like the liquid and the solid. However, they're just bouncing off the walls and hitting one another. Now, if we have a solid that changes into a liquid, a phase change, that's called melting. So put an ice cube on the table. That's melting. That's a phase change. That is a physical change. We've not created anything new. It's still, if we're talking about ice, H2O. When it melts, the liquid, our puddle, is H2O. And now, if that liquid sits out in the hot sun, it will evaporate into a gas, and we would just call that water vapor. And again, evaporating is a physical change from a liquid to a gas. Now, there are some things, and this is really cool, where at a certain temperature and pressure, it goes directly from a solid to a gas. Skips the liquid phase altogether. Dry ice is the most common thing that you may be familiar with that does this. It goes directly from a solid to a gas. That's called sublimation. Now, if we go in the opposite direction, if we have a gas and it goes down to a liquid, we call that condensation. So if you have a cold can of soda sitting out and it starts forming liquid droplets on the outside, that's from the cooling of the air, and then it's condensing down into a liquid and collecting on the outside of your soda. If we've got a liquid and you lower its temperature low enough, it forms a solid, or you've increased the pressure enough, we call that freezing. And you can have something go directly from the gas phase down to the solid phase, skipping that liquid phase altogether, and that's called deposition. For this video, I want you to know for sure that all phase changes in matter are physical changes. The identity, the chemical formula, for instance, water, it's H2O. That does not change in a phase change. That is physical. That's a physical change. If you have a chemical change, know the signs of a chemical change. A temperature change, formation of a solid that we're going to call a precipitate, color changes, bubbling due to the formation of a gas. These are all signs that the identity of our matter has changed into something new, and that is a chemical change. And finally, just to review, matter has physical and chemical properties. Physical and chemical properties. And those properties can be intensive, where it doesn't matter how much you have. So again, all chemical properties are intensive. And then there are extensive physical properties, where it does depend on the amount of matter that you have. If I had a piece of copper wire and I measured the length, but if I had more, I measured the length, the more I have, the longer it would be. So that's an example of an extensive property. The more of the substance you have, the more of that property. But if I took a piece of copper and I got its density, and we're going to do a unit on density, where that's mass over volume, no matter what size piece of copper I have, its density is always going to be the same. So that would be an intensive physical property. So we'll see you tomorrow, and we are going to be doing a lab on chemical and physical properties and changes.